Okay, topic for this video is going to be interior and exterior angles and circles. And our essential question is going to be, how are the measurements of angles formed by chords, secants, and tangents found? A little background information. Our guy Euclid. Next, Euclid investigated angles formed by intersecting chords and secants. Euclid, the father of geometry, of course. So let's see what his first little theorem said. It said interior intersection theorem. If two chords or secants intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intersected arcs. So let's look at angle 1 here. So angle 1 should be equal to half the sum of arc AB and arc BC. So that would be 1/2 the sum of the measure of arc AD plus the measure of arc AB. Or if we don't want to do the 1/2, we can do 2 times the measure of angle 1 equals the measure of AD plus the measure of BC. Oh, and I'm sorry, I said AD and AB. That should be BC. There we go. So it is 1/2 the measure of the two arcs that it kind of intercepts there. So let's give it a shot here on example 1. We've got angle X, or not angle X, but we've got our X right there. So that should be half the sum of this arc plus this arc. So X should be, not plus, sorry. X is equal to 1/2 of 50 plus 40. 50 plus 40 is 90. So X should be 45. Example 2 here's got the X in a different spot. Now, here's the angle. It's intercepting that and that. So in this case, I think that it would be perhaps a little bit better for us to set it up using the 2 times angle approach. So 2 times the angle is equal to arc plus arc. 2 times the angle is 80. It's equal to X plus 30. So if I subtract the 30, I get 50. Example 3, we've got our angle here. It's intercepting these two arcs. So I'm going to set it up with the 2 times angle version. So 2 times 110 is equal to 10x plus 10 plus 4x. So 2 times 110 is 220. 10x and 4x make 14x plus 10. So that'd be 210 is equal to 14x. And then all we got to do is divide. So 210 divided by 14 gives me 15. Now, in this case, let's plug it back in to make sure that that looks okay. 10 times 15 is 150, plus 10 is 160. 4 times 15 is 60. And then is 110 the average of those two things? Let's find out. 160 plus 60 is 220. Yeah, and 220 divided by 2 is 110. So that looks good to me. I'm going to give it a check because I checked my work. All right, let's go to the inside and see what else we got going on. So this says, afterwards, Euclid moved on to angles formed on the exterior of circles by secants and tangents, and he came up with the exterior intersection theorem. And this says, if two secants or tangents intersect outside a circle, then the measure of the angle formed is equal to half the difference of the measures of the intercepted arcs. So in this case, our angle's on the outside, and it's going to be equal to 1/2 the difference of the two arcs that it intercepts. So this would say that the measure of angle 1 is equal to 1/2 the measure of AD minus the measure of BC. Or we can do the 2 times the angle version, where we just say that 2 times the angle is equal to just the difference. Sometimes it's going to be easier to set up one or the other. All right, so let's take a look here. So in this one, we got our angle X over here. We've got our big arc and our little arc. And we know that the angle is equal to 1/2 the big arc minus the little arc. So 135 minus 125 is 110. And half of 110 is 55. Let's keep going here. Looks like we got a little algebra on this one. So there's our angle, there's our big arc, there's our little arc. So let's go ahead and set this up. I'm going to do the 2 times the angle version. So I'm going to say 2 times the angle is equal to the big arc, 10x plus 40, minus, and this one is this is an expression with that x plus 8, so I'm going to actually put it inside parentheses, because sometimes when your small arc, your little arc that you got to subtract, has more than one term in it, you really want to make sure that you're subtracting the whole thing, and not just the first term. So put it in parentheses, because that can cause some problems sometimes. So 2 times 70 is 140. And here's what I mean by causing some problems. I'm going to act like I'm distributing a -1 here. So this would be a minus x and a minus 8. It's really that minus 8 that can trick people up sometimes. Now let's combine some like terms. 10x minus x is 9x. 40 minus 8 is 32. Subtracting the 32 is going to give me 108 is equal to 9x. And so x is 12. Now in cases like this, really important to plug back in just to make sure that everything went okay. If x is 12, then 10 times 12 is 120, plus 40 is 160. And then 12 plus 8, x plus 8 is 20. So let's see about that. 160 minus 20 is 140. And 140 divided by 2 is 70. So look like we got that right. X is 12. Okay, let's go check out our last ones. So now we've got the secant tangent and the 2 tangents. Now both of these are going to follow the same kind of, the same exterior intersection rule. They just look a little bit different. So in this case, angle 1 over here is going to be equal to 1/2 the difference of these 2 arcs. So angle 1 would be equal to 1/2 the measure of AC minus the measure of BC. Or 2 times the angle is equal to the measure of AC minus the measure of BC. So same options as before. It's literally the same theorem. It just looks different because we got a secant and a tangent instead of just two secants. And then last one, you'll see that it is still the same idea. The angle is going to be equal to 1/2 the difference of the 2 arcs again, but this time it's with 2 tangents. So 1/2, oops, forgot my 1/2. 1/2 the measure of that big arc, which does look like a major arc, so I'm going to use 3 letters, ACB, minus the measure of arc AB. Or once again, we can set it up with the 2 times version. This would be 2 times the angle equals the measure of ACB minus the measure of AB. So once again, same options as we saw with the secants. It just looks different because it's tangents. So let's try one out here. We've got a secant tangent here, so hits that arc as our little arc, and this arc is our big arc. So I would say, I think I'm going to set it up with the 2 times angle version. So 2 times the angle equals the big arc minus the little arc. 2 times 50 is 100. If I subtract the 160, I get negative 60 is equal to negative x. And then dividing or multiplying by negative 1 gives me that x is 60. So if this is 60, let's just check to make sure that that works. 160 minus 60 is 100. And 100 divided by 2 is 50. So looks good to me. X is 60. For this one, we got 2 tangents. So the angle should be equal to 1/2 of the big arc minus the little arc. Now, we don't actually know what the big arc is, but we do know that the entire circle is 360 degrees. So 360 minus 80 gives us 280. So this big arc's got to be 280 degrees. So now I'm able to say that the angle x is equal to 1/2 big arc minus little arc. That'd be 1/2 of 280 minus 80 is 200. So that means that x should be 100. And in this case, we don't really need to check because it's just, we would just be doing the same thing, right? 280 minus 80 is 200. Half of that is 100. So we're good. Now for this last one, it says solve for x. This one's a little bit trickier. Here's the angle, right? And that angle should be this arc minus this arc divided by 2. Now, we don't know what that big arc is, and that 14x plus 10 is not really helping us right now. Here's what I'm going to do for the moment. I'm going to put a y over there, and let's figure out what that big arc is. So we would know that 2 times the angle, 2 times 40, should be equal to y minus 65 if we set it up using the 2 times the angle version. Now 2 times 40 is 80. It's equal to y minus 65. If I add the 65 over, I'm going to get 145 for y. Okay, so we figured out what that big arc is. Now what we've got is a situation where we've got the measurements of all 3 arcs that comprise the entire circle. And we know that the entire circle is 360 degrees. So I think this is what I'm going to do. I'm going to do 14x plus 10 plus 145 plus 65 is all equal to 360. Now what we can do is combine those like terms. 145 and 65 is 210. 210 plus 10 is 220. And then if I subtract the 220, I'm going to get that 14x is equal to 140, which is pretty nice because that means that x is 10. If I plug that 10 back in, 14 times 10 is 140, plus 10 is 150. And then let's just double check that it works. 150 plus 65 plus 145. If I add up all of that, I do get 360. So everything worked out. So a lot of different situations we can find going on with these situations. Big idea here is that if you've got an angle on the outside, you're doing that the angle is equal to 1/2 of big arc minus little arc, or you could say 2 times the angle equals big arc minus little arc. And if you've got angles on the inside, like we first looked at, it's with addition. So the angle is equal to 1/2 of the arc plus the arc, or 2 times the angle is equal to arc plus arc. It is now your turn to try. So go ahead and take a look at those 6 problems on the your turn. You've kind of got like one basic version and one kind of trickier algebraic version for each one. Give them a shot and then come back to the video when you're ready to check. All right, hopefully that went well. I'm going to go ahead and say that x is equal to 1/2 of 63 plus 41. That'd be 1/2 of 104. So x should be 52. For this one, I'll do 2 times the angle equals arc plus arc. That'd be 240 is equal to 9x plus 15. Subtract the 15, I get 225 is equal to 9x. And is that 25? Yeah, that's 25. Okay. For number 3 here, we'll do that the angle is equal to 1/2 of arc minus arc. That'd be x is equal to 1/2 of, what is that, 102? So x should be 51. For this one, I'm going to do 2 times the angle is equal to arc minus arc. So that'd be 24 is equal to 6x minus 4 minus 3x plus 1. That is a little tricky when you're distributing the -1, then the 3x minus 1 becomes a minus 3x plus 1. So this would be 24 is equal to 6x minus 3x is 3x, minus 4 plus 1 is minus 3. Add the 3, we get 27 is equal to 3x, so x should be 9. For number 5, if the big arc's 300, the little arc is 60. Got to add it to be 360. And then we'll just do x is equal to 1/2 of 300 minus 60. So that'd be x is 1/2 of 240. So x is 120. And lastly, this one's a little bit odd. Let me go ahead and call this arc y right there. I would know that 55, or 2 times 55 is equal to 160 minus y. That's 110 is equal to 160 minus y. It's -50 is equal to -y, so y is 50. So this arc has to be 50. And then if all 3 of those arcs have to add up to be 360, then I could do like an equation like this. I could say that x plus 50 plus 160 is equal to 360. That'd be x plus 210 is equal to 360. So x has to be 150. That one's pretty tricky. If you figured that one out, give yourself a pat on the back. But that wraps up everything here. Hopefully that went well, and I'll see you next time.